And then we'll continue with the next speaker, which I'll invite Dr. Brian O'Reilly, who is a senior scientist at LIGO, and also the LIGO-India liaison from the US LIGO.
And I'm going to sit down. So I didn't make slides for the panel discussion, but the question that was posed are, what are the challenges that LIGO-India faces based on our experience with LIGO in the US? And so on the face of it, it's kind of a strange question, because ideally, if you come along with building LIGO-India, you're in a great position to avoid all of the mistakes we've made with LIGO in the US. And we made lots of missteps. We learned over 25 plus years how to approach building and operating an instrument as complicated as LIGO. And not everything that we tried to do for advanced LIGO worked out the way we intended, at least the first time. And so there is a great capacity for acceleration in commissioning and getting to higher sensitivity for LIGO-India. And so I put down some thoughts. And so my 4 thoughts that I was going to talk about is that 1, we should learn from our mistakes. So LIGO-India should learn from what we did wrong. The second point, I think, is that it's really important to get to the low noise operation of the detector as fast as you can. And the third point was to start work now and try to build a model. There's still efforts in the US to build a good working model that mirrors the operation and function of the detector. But that's still not a mature thing. There's not a model that we can go to that faithfully reproduces the behavior of the detector. And you can learn a lot about that. I'll talk a little bit about that later on. And then the 4th thing, I think, is that you have to train lots of people, because you won't keep all of them. You won't want to keep all of them. You'll want to keep some of them that you won't be able to keep, because they'll be headhunted away by Einstein Telescope or industry or Cosmic Explorer. So you'll want to train lots of people, and you'll identify along the way a core group that will work on commissioning, but equally important, a support crew that will help you. So I'll make a few comments on those. So the first thing, learning from our mistakes. So in principle, it sounds great, but the issue, of course, after 25 years is, can we actually remember what our mistakes were? And have we written them all down? So it's very common for something to come along and somebody says, oh yes, I remember 15 years ago, we came across the same thing. And then you recreate it, and there's going to be some of that. And so I think the best way to approach that is, we have 25 plus years of documentation from the electronic logbooks, from the document control center, from commissioning talks, and it contains a lot of information. And so people need to, and we've already heard at this meeting that there's ways to process that information with some modern tools to make it easier to search. And so you can avoid the famous Santana quote of, being condemned to repeat history if you don't actually learn it. And so I think that's one important thing. But there's also a cultural difference. And so one of the things I've noticed is that there's a reluctance for people in India sometimes to document work that's incomplete. I mean, everybody probably has their lab notebook, but they don't want to show that to like a large community of people, because it's got mistakes, it's got musings, it's got thoughts. And this is a problem we confronted on LIGO as well. And even to this day, there's some people who make log entries that are very brief, because history has taught them that if they write too much, then they get, kind of intense questioning. Unsurprisingly, physicists are not very socially adept. And so when we argue with each other, it looks like a continuous fight to what I would call civilians. And so you have to somehow not just educate people to document what they're doing, but also educate their bosses that if somebody puts something in the logbook and it's wrong, that the boss doesn't go, oh, I can't believe you did that, now we all look bad. It's just like part of the process. And I remember, like when I was thinking of how to put this, right after the first detection, there was a crazy couple of weeks, and Ray Weiss came to Livingston. And at the time of the detection, we had just started the observing run, and Ray was on vacation in Maine. So the detection happens at 20 to 5 in the morning on a Monday morning. And as it became clear that we had detected gravitational waves, we started to shut down lots of ancillary activity at the site. We canceled Tuesday maintenance. We made all these edicts that were in the log about you can't do this and you can't do that. And Ray is sitting in his holiday house in Maine, and he read the log from both sites every day, and he's like, oh my God, they've broken something. Something terrible is going on. It looks like a disaster. And after years and years of going towards this. But what struck me later thinking about this is that what Ray didn't do is he didn't get on the phone and start calling people and be like, what the hell is going on? He had to wait like a couple of days before people were relatively sure, and they were like, okay, let's tell Ray. But he didn't start calling the control room because he knew from the process that what people were doing had a good motivation. And I think that's a good example, maybe a great example of reading the log and learning, he knew something was wrong after years of people carefully documenting what they were doing, but also having trust in the people to be making those entries for a good reason. So the second part, which in Livingston, our history with the detector was very fraught in initial LIGO. It was very difficult to lock if the microseismic noise was high, if people were cutting trees. I joined LIGO just before the first science run. We started the science run, and the next day, they started cutting trees a couple of 100 meters away. It was almost perfect timing. And so for a long period of time, people would come to the site to do some work. They might come for a week. They might get one good stretch of locking where the interferometer could reliably operate. And it's very difficult to make progress like that. It also turns out that no matter how many measurements you make of the electronics and you can check the suspensions are working properly, you can check the electronics, the seismic isolation, the laser, until you actually lock the degrees of freedom of the instrument. Only the instrument is sensitive enough to tell you if there's a problem with the instrument. And so you don't really see the noise, and you can't really make good progress until you can reliably lock. And so I think as Sendel mentioned, there's going to be quality control. People have to do a careful job of putting it together. But then we'll also have to decide what kind of upgrades we do and what kind of downgrades we do. Because a lot of what works in the current 2025 version of the LIGO interferometers will not easily translate to a 2014 interferometer. And so I think, we don't want to change too much at the start. We want to build the instrument, and we want to get a fundamental first look at that 50 to 100 megaparsec. I think LIGO Livingston from April to October went from first lock to 50 megaparsecs. And then quickly, we got to about 75 megaparsecs for 01. Hanford came second. They started a little later because they did other things at the beginning. They got very quickly to the same sensitivity. And so I think with LIGO-India, you want to get to that sensitivity, and that lets you make contributions. It lets you detect, almost inevitably, you will detect some binary black holes, which I think will be a big moment for India and for LIGO-India and the global community. That will be your baseline. We did it. It's time to build to like 200, 250, 300 megaparsecs. And then the thing about getting to low noise is that you get there, everything looks great, and then something breaks. And even the experts, the people who know things backwards and forwards, can spend several days trying to figure out what's going wrong. Sometimes it's that you can't lock the interferometer, which is really difficult because there's so many ways it can break. Sometimes it's you don't know why the noise is not what you predict. And so that's where this idea of building a modeling the detector, and I don't mean just running finesse and modeling the optical fields, but building either a digital twin of the detector with the controls and the loops, or actually building a sophisticated finesse model and comparing it to the current detectors. So you have the opportunity coming with LIGO-India that LIGO Livingston and LIGO Hanford have tons of data where you can build something and say, does this actually match what we see in reality? And then, like the last thing, and then maybe there'll be questions, the idea of people. So it turns out, and some of the commissioners will say this, there's only so much room in the control room. So a model where you have 50 people commissioning the detector doesn't really work. You usually will have an order of 10 people who work on commissioning noise reduction. But you'll have a lot of people who are subsystem experts and who are basically working on making the seismic isolation system perform at the optimal level, or maybe increasing the power that you can have at the detector with thermal compensation, or working on squeezing, or working on the suspensions. And so you have this, at LIGO at the moment, we have detector engineers. And so one of the lessons that we've learned well from initial LIGO is that we do better configuration control. But we do it in such a way that if people are working on an upgrade, we don't make them stop and do paperwork. We have a team of people that comes along after the fact and makes sure that all the paperwork is done and that we know how to reproduce the condition that we're in right then. And so it's important to make it, to have configuration control, but not to weaponize it to slow things down. So, and that's something we've seen in other experiments where people are unable to make progress because somebody is saying, the procedure says you have to write this document first. And so we haven't done things. You have to be freewheeling. And the other thing, of course, is that 2030 can seem like a long way away when we're looking at recent advances with machine learning and AI agents. And so we don't know what the control room will look like in 2030. We've just started to use fully or almost full automation for the LIGO detectors. I expect that that will be more and more true. And there's even a recent paper with Jan Harms, who's here, and Ron Adhikari, and some people from Google, and some people from Caltech, and the sites, where they've done this deep loop shaping to try to improve the noise in the detector. And that's probably an augur of things to come, so that a lot of the commissioning efforts that we did in initial and advanced LIGO will be radically changed. How we design loops, how we make stable loops, how we understand the full several hundred loops and how they interact with each other. That may all change. And so it's going to open the door to autonomous operation. It's also going to allow us to do things like have perhaps an AI model tell us that it thinks the noise is coming from this particular subsystem or this particular area. Now, maybe it'll hallucinate, but I think this is one of the things that will get better over time. And it's something that, again, there's an opportunity to look at what we're doing right now. And I think if LIGO-India comes online and it's basically using the same set of Python scripts that LIGO uses right now, then that's an opportunity missed. And so there are ways that we're working, Sendel, people from IUCAA, from IPR, to train people. So there's an opportunity for people from India to visit the United States, either on a visitors program, either on LIGO-India funds. There's also an LSC fellows program, which will probably expand to an IGWIN fellows program, where people can actually go and work at the sites and get basically experience you can't get any other way. There's only so much you can learn sitting at a computer and simulating what might happen. So I think that was the bulk of the comments that I wanted to make. So I don't know if there's going to be a discussion or if somebody else is going to weigh in. Over to you.
Thanks, Brian. Any specific question for Brian right now? Ajith, go ahead.
A sense of what fraction of the sort of issues are site-specific as opposed to common between LIGO, Livingston, and Hanford? You get a sense of how many of wisdom that you can use here in LIGO-India?
So the overlap is quite high. There's definitely differences between the two sites. I always use this, I guess it's a Superman reference, that you go into Bizarro world when you go from one site to the other. Like little things are different between the two sites. The control rooms look very different, but they're essentially the same detector. And so there's one of the things we've learned is that we make changes and then we commission. The other thing we've learned is that we'll make changes at one site first, and then we'll work out all of the bugs, and then we'll make the same change at the other site. And so that systematic approach to making changes, I think, will also really help LIGO-India, because when something comes here, at least at the beginning, it will probably be the third time we're trying it. And eventually, of course, things will come the other direction. It'll be tried first at LIGO-India and then second at one of the US observatories.
I was just going to ask about the detector model. So for many years, the LIGO lab supported Hiro Yamamoto building an end-to-end model. What's become of that?
So I'm not actually sure. I think that there's still, so Hiro has retired, but I think he still works a little bit on responding to questions.
Is that the model which you'd like to have sort of brought up to date and made current, or are you thinking something else?
No, I know there's an effort to essentially start an interferometer modeling group that will tie in closely to commissioning, and that won't be limited to just one or two people. So Hiro was very responsive, and some changes were informed by simulations and calculations he made. But now I think people are trying to get something that works more at the coalface, if you like. And so that's responsive to, so one of the complaints often is that people will build a model, but their input parameters don't actually match what's at the detectors because there's a communication breakdown. And so I would say that we still lack a comprehensive model of the detector, and that's an opportunity for people to build one of those.
Okay, so if I understood right, the end-to-end model was following the detector, but not really actually helpful in the commissioning and understanding of it.
Yeah, I think it was helpful, but not as helpful as, I think it was helpful in designing and looking at the effect of changes. So maybe the most recent one is the bigger beam splitter that they're installing for next year, basically, because the simulation pointed out that we were probably aperture limited by the current beam splitter. So it does have an effect, but it wasn't at the level of, can you understand the scattered noise by going to this model? Or can a large group of people run this model and produce, can you give it to a student and say, hey, tell me, what the scattered light will look like if we put baffles here or here.
So in your dream world, would that model be extended, or would one simply start over and do it again from scratch?
That I don't know. I think it's probably not a start over from scratch, but I'm not sure what I know that the effort has been restarted, but then one of the things is that people who were working on it, some people have left, there's been some turnover. So I'm not sure where it stands right now, but if there are people who are interested, then I can put them together with the group who are really attempting to boot this up again, I think, so that we don't lose, now that Hero has retired, we don't lose all capacity to make a simulation.
I think also AI/ML has to be integrated now in the new models, because you don't want to really model by hand, rather let the machine learning learn how the system is responding, and that will sort of shortcut different steps, I guess. It is like digital twins and so on.
Yeah, so I'd be careful, because if you tell the commissioners you're going to build an AI model of the interferometer, they'll either expect you to give up after a few months, or that maybe years will go by and then eventually something might be produced. So I think that there's a deeply pragmatic turnaround aspect that I think a model should work with over the next couple of years and build out the infrastructure for something like very fancy and far-reaching. I think it's an opportunity for people to research if they can build an AI-based model.
Yeah.
But I'm not sure that will be application ready. It has a chance to be application ready for LIGO-India. But for the current LIGO detectors, say by the next time we run, which now is next year, probably not.
I mean, it could be subsystem specific initially and then globally connected. Then there is a clear goal for each one of those. Well, I mean, it could be Bruce is asking how we train it. I mean, the training could be based on response of each of the subsystem. See, there are some inputs, something we have to think thoroughly and how the system is responding. And if there are some test, somehow you can probe it. Let's say we do a sweep generator and probe a certain subsystem, the way that people test a subsystem. That's how we can model it. And then later on try to see if we can integrate it in a bigger way. Because the whole global model of detector would be really difficult to approach.
Sanjit, may I respond?
Yeah.
Yeah, regarding modeling the interferometer using AI/ML, I think we don't want a complete black box where we just generate the inputs and outputs as it is in reality. I think we would like to understand what goes on inside the detector to be able to make changes in a constructive direction. So we would like a physics-informed AI model. For example, there are some portions of the detector which we would like to understand from a optical, mechanical, and electronic perspective. But there are some portions of the detector maybe we don't want to understand. Those can be reduced to black boxes. One example was recently the AI/ML technique was used to sense the oncoming of a earthquake far away. If an earthquake happened in Indonesia, we wanted to somehow protect the detector from completely unlocking. So an AI/ML model was used to simulate what will be the disturbance at the detector, and then we could respond to it before the earthquake actually arrived. So what was unmodeled in this part, not analytically modeled, was the actual response of the Earth, which we did not need to understand. We only needed to understand what arrives at the detector. So there will be models which we do not need to know the details of. Those could be AI/ML black boxes, but the rest of it, I think, should be understood.
Well, physics-informed neural networks is also part of AI. I think there are people who are working here on that.
Yes.
But on the other hand, I did not mean a blanket, take something off the shelf and do it. So Archana has a hand up. Archana, please go ahead.
Hello. Yeah, good morning to all of you. So I am quite curious and interested in Brian's remark that so I think we had this discussion about this end-to-end model with Rana at some point. And basically, I think what Rana was saying is that we need some model which has also, response of servo and feedback and things like that. That is what we are looking for. So in fact, I asked him this question, if there are some people, if they're interested to develop this model, then how, do they have to be experimental people, or, how does this interface happen? So I think what the comment which you made, that, if people are interested, you would like to get in touch with them. Do you have more inputs on this?
I'll say let me make one comment on the AI. Let's just call it the AI approach to this. So I think there is a capacity. So I take Suresh's point that you don't want a black box, but a lot of what you're doing when you're commissioning the detector is you're trying to make stable control loops. So you're trying to measure some transfer functions and design some stable control loops and understand the multiple interactions. And right now that's kind of done by brute force. People make a control loop, and they make, they get that working, they move on to like 15 others, and then they circle back and they find they can optimize the control loop that they made at the beginning. And so I think you can speed up that process by having an optimization process that is something of a black box, but gives you some stable control system that you can then measure and understand. So how it got there is probably, the speed it gets there is probably more important than the brute force logical approach. And you don't really need to know why is this loop stable or what did it find. You can dig in and usually look at the plant and see why that loop works once you have the loop. For Archana's question, I think I'm wary of just saying, let's get people who are interested, because then you go to the commissioning modeling team. And so I think if people are interested, I would like, them to contact me and say, I think one of the ideas that's been floated is to have some kind of a workshop, maybe at IUCAA, that focuses on this modeling, especially as related to commissioning. And I think that would be a good forum to get started. Because I think what sometimes happens in LIGO, people say, we'd really like to work on this. And then that creates kind of a lot of work for the people who are trying to build out the group. And they always don't feel that they get productive product out of that they get a good result. So I think we have to be careful how we build this up and engage people who are already highly subscribed. And so it has to be better thought out than just this conversation here. But I think that pathway of finding groups who are interested in doing this. And one of the things we've talked about on the US side is that there's a lot of theoretical and data analysis work that goes on in India. But there's a model where Kip Thorne's group over the years produced many papers that were of use to LIGO, both initial LIGO and later on. And so I think there is a model there where people can say, I can do things that Kip Thorne did in my group and find some interesting problems and do some calculations that can be useful for LIGO-India. And so I think that's true as well for the modeling part. And again, if you say it's a machine learning AI approach, it may not pay dividends right away, but it's a good way maybe to get people engaged because they feel they're developing a skill set which, at the very worst makes them employable, and at the best could revolutionize some of the things we do.
Okay, thanks, Brian. So I think we stop this talk here. And since the discussions are going pretty well, I'm not interrupting, but we may need a little more time in the end. I just want to make one comment from your this thing, that let's hope that when LIGO-India starts engineering run, we make a detection. That happened for advanced LIGO. That cannot be ruled out, right?
As one of the other hats I wear is run coordinator. Making a detection during an engineering run is very disruptive. It's a
Somebody's entertainment is somebody's disruption, as you know.
but yes, I think once you get to low noise, I mean, we know right now, once you get above 50, 60 megaparsecs, if you stay locked for an appreciable amount of time, you're going to see binary black hole merger. It is written, if you like. So, and you know, once you get to 100 megaparsecs, then your engineering run will definitely give you binary black holes. And of course, there's always the chance that you see something spectacular, and then you have to worry that your calibration isn't complete and your detector characterization isn't complete and you're the only one that saw it. And so it gets complicated. It can really mess up your plans for an observing run. But, you know, for advanced LIGO, I would say we were on the cusp of pulling the trigger to start observing anyway. So it was less disruptive than it might have. I mean, it was insanely disruptive because everything became a meeting for like 2 months, but well, 4 months, but in a good way.
It will boost the momentum then after that impulse. Yeah. So let's hope so. Okay. So now I think I think we close this one and then we'll again sit together at some point if there is time. Okay, let's thank Brian for the nice session. So I would like to invite now Dr. Subrata Mukherjee from IPR. He's the Dean Administration there and also the LIGO-India Project Coordinator at the Institute of Plasma Research, to share his views on what he feels would be the challenges for LIGO-India.
Good morning to all of you. I am Subrata Mukherjee, coming from Institute for Plasma Research. And I'll be telling you about the responsibilities of the LIGO-India project, which lies with us. And as you know that the EPC contract is already on. There is a date for the bidding very soon. So what I'm going to tell you is that what do we think as the challenges, both in terms of making the observatory. Now, this is nothing to do with the runs, which would be happening at a later stage. This is basically the EPC contract, which is civil, mechanical, and vacuum put together. Now, this slide has many pictures, but each picture has something to tell about the LIGO-India project. Now, it's a pointer. Okay. Now, let's start with the top leftmost picture. This is February 2018. So, nearly 8 years, 7 years plus 10 months, something. And you can see myself, someone among the middle one, in the 3 on the top, and Dr. Senthil Raja, who gave the presentation, Dr. Tarun Saurudip and Mr. Milim Govardhan. So we are 3 are from the 3 institutes. He's from, currently. So he was the project coordinator from IUCAA at that time. I am from IPR, Dr. Senthil Raja from RRCAT, the project coordinator, and Mr. the Milim Govardhan. And you can see over here is a pillar, what you call a pillar, in which LIGO is written over here. So this is essentially the 00 crossing, that is the BSC chamber in which exactly the light gets split. That is the location. But it was, and you can see the terrain in the month of February, the backside, it is completely dry. Everything is brown. So it is right on the top of the Deccan Plateau, where there's hardly any rainfall and hardly any the vegetation in that place. Now, 2 of the people, so today, if we have to take the same picture, so Dr. Senthil Raja and myself are still there, and here it will be Sanjit, and here it will be Samir Jadhav. So Sanjit is here. And after some time, maybe I'll not be there, my colleague Vijay Berkiale would be there, and like that way. So many people would be changing as time progresses. Now here comes the 4 kilometer that already you had seen during Senthil's presentation. So these are the 4 institutes, IPR, Institute for Plasma Research, making the vacuum as well as the control and data systems. Responsibility is with us. Then there is RRCAT, then there is DCACM, and this is IUCAA. Now, DCACM is the civil construction wing of Department of Atomic Energy. They make various buildings. I don't know about this building. Ideally, they are supposed to make this building also, because ICTS is under DE, part of TIFR under DE. So they are making the lab, and this is how it looks like. Now, over here, if you see, this is 4 kilometers on this side. So this is the X arm, and this is the Y arm, and these are some of the buildings. This particular building is actually ready. And this is now the site office. Later on, it will change to some other activity. Now, initially, we got something like around 150 crores, roughly divided as 75 to DCACM and 75 to the remaining 3 people, with the 3 institutes, to do all types of prototyping and get the land and see that it is fencing is done and do certain the year-long the measurements. So DCACM did that, and this is a remarkable job in getting land in India, which they did. And that too with less number of controversies or things like that. Now, when it comes over here, I'll actually go into a little bit detail about these slides. These are basically the BSC chamber, the ham chamber, the 20-meter prototype along with the gate valve and a 80K cryopump. And this, when we told that we will be making the prototypes, we decided to make 1:1 prototype. So full size, it is not making a small chamber of things. So that, and we have to make it within the country. And so we have to hunt for vendors who are ready to take up this job and do it. And then achieve the parameters, at least most of the parameters close to the LIGO requirement. So this I'll come in more detail later. This is the LDAS facility at IUCAA, probably from the same funds as I told. Now, IUCAA funded. And now this is a picture. This is basically when the Honorable Prime Minister, he did the inauguration, online inauguration. There are these plaques which are made in 4 languages. So these plaques are now actually at the site. So this is DCSM Director, Dr. Mahapatra, then Brian. You can make out Brian from the height difference amongst all of us. And my colleagues are there, and DCACM colleagues are there. So this is exactly at site. And this is in 4 languages, Hindi, Marathi, Sanskrit, and English over there. Now this is the training center, which Dr. Senthil said, which was inaugurated about a year back. And a lot of activities happened. And this is the 10-meter facility. So with all this background experience that we had, nearly from 2018-19 till about 23-24, all that resulted in making this the tender, EPC tender, which is civil, mechanical, and vacuum. And this was published in April 16, 2025. Now, yesterday, you could see the first page of the tender, which Dr. Bruce showed. And so it is actually open. Anybody who wants to know what is there in the tender, and you just have to type EPC, LIGO, DCACM, something in Google, and this will come up. You can download everything that you want to know about the tender, like what the technical specs are. For that, you don't need to have any account or something. It's only one who wants to bid will have to create account. Now, so this is not a challenge, but so the challenge part comes on the site later on. This is just to give you an idea. This is total about 428 acres of land in this shape, with some width over here around 150 meters is the width. Of course, we're not going to use 150 meters. We're going to use much the narrower part of it. And then we have the end stations. Here you see this is the filter cavity and another small, what to call the end station for the A+ configuration. Currently, though the A+ optics may come later, all the provisions from civil and vacuum is already inbuilt in this one. Now, while we do that, you please remember, see there are 2 major differences over here. In the LIGO US, even the artist impression, there is always a mid station. Now we don't have any mid station in this one. It is the corner station and directly the end station. So 4 kilometers of beam tube is a continuous construction, one single piece, which would be made by joining various small pieces. So this is one change. And this A+ filter cavity is actually parallel to X arm. In LIGO, it is parallel to Y arm. It starts like this and then it ends in this way. So these are 2 major changes which are there as far as. There are, of course, other changes, like we have all the cryopumps are of same dimension and other things which are there. Now comes the challenges. Now this place, if you remember the first picture, the background you can see a little bit on the, if you see this background, the place where we are standing, you can see some small ups and downs. So that entire land is like that. Though it is seismically very silent, but it is like that. So then comes the challenge. The project requirements is that you have to have an absolutely flat platform, even beating the curvature of the earth. But the place is like this, up and down. So this is like in the one side, and that is in the other direction. So this is arm X arm, and this is the Y arm. So all this has to be cut and filled. So what we have to do over here is that highly undulated topography at site, and also the slightly below the surface it is rocks. So a high volume of cutting and filling has to be done. So we cut here, so that itself takes a lot of time, the ground leveling. It's not an absolutely flat like people who have gone to, say, the Hanford, it's absolutely flat. Or maybe in Livingston also, nearly flat. But here it is actually up and down. Also, to do that, you may have to use certain amount of explosive, blasting at that place to break the rocks, which are slightly below the surface. And also what is not written here, that there are some, because this is a long, there are some natural streams, which of course are not there for 11 months, but during the monsoon season, they come. We have to also have path for them, which are there. There are no wild animals, but certain times some deers also come from here and there. So a nilgai, there's an antelopes, one of the family of antelopes. They come, so you also have to give path to them. Otherwise, they will run along the 4 kilometers and then go on the other side, something like that. So these are small challenges, but these challenges sometimes we have to ensure that it is there built in. Now, we will be having, this is the beam tube schematic, and we will be having these enclosures, the RCC enclosures continuously, and there will be entrance doors at some the locations. Now this platform has to be having the same amount of accuracy or better accuracy than what was there in Livingston or Hanford. And that is pretty tough over here to get, but we have to get that one. And then also the tolerance of the beam tube supports over there. Remember that this location is a very remote location. So to get the kind of expertise which I'm going to come over there, it's a little later. We have to get all this hardware, all the instruments to put this thing exactly at the location where it is intended. So this is mostly, there are many other challenges, but I thought that I'll just put two major ones, civil. And then of course, there's a certain sequence the buildings have to be made. Now comes our effort towards the project in terms of vacuum chambers. Now, firstly, we had to go, before this was being done by a contractor, Measures Vacuum Techniques in Bengaluru. We made we traveled, myself and my colleagues traveled nearly the entire country to find who has the capacity to make such large size chambers. And that too have ultra high vacuum compatible chambers. So there are a few of them, and Measure Vacuum Techniques happen to be one of them. So we made 1:1 size the BSC chamber. This is the BSC chamber, and this is the ham chamber. Those who are familiar with the LIGO terminologies and may have seen the facilities in Livingston or Hanford knows that this port is a bit critical. This one and one which is just behind it, this one. Because they are not exactly at normal to the circumference. They are slightly at a different angle. So this took a lot of time for this vendor. We actually to make something in mock-up, because he fixes something and after the welding, when it cools down, then it is exactly not. So these two ports are not seeing each other. Bit offset is there. Of course, we have extremely good support from the vacuum review board, especially Dr. John Fight, who sort of guided us nearly on a daily basis that you first do this, then do this. And I will tell that we are very grateful to him, and he continues supporting us even now also. So this type of, then over here also, we found that we have to have these things perfectly aligned. But then we find after the collar flange is welded, the collar flange itself is not very parallel. It has a bend a little bit. Again, we had to de-weld and again do the welding once again like that. So some numbers for you to get a feeling, people who may not have seen the facility, that this height is about 5.2 meter, each of this one, the BSC chamber. Other one is 2.9. So wall thickness is like this. So this height and this diameter, and we have to see that the helium leak rates are as per the LIGO requirements. So whatever was the LIGO requirement, we actually met all of them over there. And now these chambers are at RRCAT, and they will be pumped sometime the later part in December, January sometime. So this, that's it. Now, we have to make something which is called as a beam tube. Now, actual beam tube is like 4 kilometer and one side 4 kilometer. And each section is about 20 meters. Now, we cannot make 20 meters inside a lab because of two reasons. We don't have a lab which will give you a space, a very long space. Maybe you can get only 20 meters, not beyond that. And also the internal roads in the institute are not made to have a truck which can take something 20 meters. So we made two 10-meter sections. Now this, so first of all, these lengths are 10 meter, 10 meter, 10 meter. But it has a cover which works as which can be used for baking purposes. There is a bellow in between, which is like a hanging bellow in exactly 1:1 as the LIGO. One major change from what LIGO did and what is over here. LIGO used spiral welding to make these tubes. There is no spiral welding for stainless steel of this thickness in the country. So we use something very conventional, basically adding small cylinders. Because we wanted to see whether other things, which is the making the dimensional tolerance of this thick 3.2 millimeter sheet, whether all other dimension tolerance, including vacuum, the manufacturing process, everything, it is exactly as per the LIGO specification. Now, this was made by a big company called Messrs. Godrej and Boyce in Bombay. For us, anyway, we all know by Godrej. One major thing for us was this 80K cryopump. Now, as you know that in the beam tube, at the end of the beam tube, both at the end stations as well as at the corner station, there are cryopumps, which primary job is to see that the water vapor from the components which are in the chambers which are away, they do not enter the beam tube, which is 4 kilometers long. So we made a 1:1 size cryopump, again, made by a very small company in Aditya, in Ahmedabad, Aditya High Vacuum Private Limited. And their small is actually very small, and we had to actually keep our person daily sitting over there to get it done. One of the changes which we did over here, now if you know, if you have idea about the cryopump, inside this stainless steel chamber, there is actually another chamber which is made of aluminum, in which liquid nitrogen is filled over there, which actually works as a cryopump. But the only thing is that aluminum is inside and this vessel is made of stainless steel. But somewhere there is a joint between aluminum to stainless steel. So these are dissimilar metal, and people who are familiar, they know that it is not easy to weld aluminum to stainless steel. They actually do not get welded. So we use other type of concept, and in LIGO USA, this joint is actually inside the vacuum vessel. So we made certain design changes and made it come outside. So in the event, if there is a problem, we will be able to repair it from outside. Again, here also, we have found out how much. They are all currently working in the range of 3 to 4 into 10 to the power minus 9 millibar. Our aim is to go to 1 into minus 9 millibar or below. But there is a problem because in this particular building, this is a huge building shared with various other labs. This is now not a clean room and things like that. So we'll take certain amount of time, but we'll reach there. This is a control and data system, again, as per the LIGO specifications, which we have made. And we have the vacuum control and monitoring system all in-house developed for all the facilities. So you can sit in one place and actually see the entire systems working. So this is the last slide. So I have written that this is the most precise instrument to be built on Indian soil, and there's some immediate challenges. This part is done. Choosing site, less man-made noise, less population, building prototypes. So this is done. This is where we are now. We will be assuming that there's an EPC contract in the next 2-3 months. The contract will be signed. Leveling the land is a challenge. Civil activities at site, construction of end and corner station beam tube platform. 8 kilometer, that is 2 into 4 kilometers, spiral welded low hydrogen stainless steel beam tube. So this spiral welding would be a learning curve for the vendor who is making it as well as for us at these dimensions. Getting low hydrogen stainless steel, we had to convince the vendors who would be taking part in the bidding, probably taking part in the bidding, that how to get it and what are the procedures to do. Alignment of the beam tube sections, then vacuum chamber fabrication. And the vendors have to finally demonstrate 1 into minus 9 millibar, 10 to the power minus 9 millibar, which of course they have to put a lot of scientific manpower behind it, and we will get involved along with them. And then installation and commissioning and engineering and science run. Now to do all this thing, we have to do this part up to this. His time is 48 months. So these are some other challenges which we have to overcome. It is not that we have a choice over there. So 48 months, now that means basically if it is signed on January of 2026, it is exactly 4 years. So we have to finish this up to here. Then getting the right contractor. I mean the contractor with who gets this contractor, he has to have a very, a positive frame of mind because it's a remote location. He has to bring manpower which are highly skilled. It is not making just a building like a lab or a guest house or something like that. It's making a lab which has very stringent requirements. Getting trained manpower during the EPC phase, that is up to here, from the contractor and the 4 institutes. Now here I have used the word trained. Basically the person who goes there, at least in his field of expertise, he must be trained enough. And from all the 4 institutes which are party to this project. And then once this is done, it comes here, availability of trained commissioners. By commissioner, I don't mean only people who are inside the machine, even outside. People will help the scientists to put all the components inside. Everything put together. So thank you.
Thank you, Subrata. We can take one quick question. If you have any, otherwise you can hold on to the final part.
One question.
Sure.
So you worked on fairly large projects in India. So among these things, which is the hardest to get? And have you found some ingenious solutions based on your experience? Yeah, among these challenges. That's a rather technical challenge, right? That if a company commits that they would do that, that's probably a technical challenge that can be overcome, is that?
Hello?
I hope it's a technical challenge that can be overcome.
Technical challenge. See, you have to do the same thing every day without any break. No Diwali, Holi, no holidays. Right. Both for the contractor as well as for us. And if we make what I learned from Fred Rab of LIGO, that LIGO on an average put 3 20-meter beam tubes per day. So 3 goes, behind this the person comes welding, 1 fits it, 1 welds it, 1 verifies no leaks are there. Then this RCC structure comes. So this is going 3 per day. If we have to make 3 per day, there are no breaks in between. It is 3 per day daily. For me, it comes that's the major challenge, that how do we keep our manpower? Now it is 8 kilometers. And if my understanding is we have to do 3 per day, suppose we come to another number, say 2 per day or 1 per day. If it is 1 per day, 20 meter, you need 400 days. Getting 400 days dedicated manpower at that site from contractor and from technical part is a real challenge. But that is manpower challenge. People will tell this is simple to solve. In my understanding, it's not simple to solve.
Are there examples of such large constructions in India where people have solved this kind of problems?
Though, first of all, such type of problem doesn't come. That you have to do everything daily on the same thing. You can make a building like this, which will be pretty complex, but you can make this half of the building, and then the half you can come after 15 days and do it. Here, it is not like that. You have to do it, so you have to do it continuously. But the main thing is making the spy, which I have not specified here, which is there in the tender, if you look into the tender in detail. We have given an option to the contractor that either you make 10-meter sections at another location, not exactly at site, maybe Nanded or Bengaluru or Hyderabad, wherever, and transport by road. That's one option. In that case, my number of welds joining 10-meter section goes up. or you make 20-meter sections exactly at site. By exactly at site means the land which I shown, some corner in that land. Now, how will he get manpower of, this is a highly skilled job, spiral welding, how will he get manpower over there? So, but I have a feeling the vendors, whatever we have interacted till now, they are thinking of putting it at site, 20-meter at site. But finally, what they write in the tender will come to me. In my understanding, this is probably the most difficult scientific project or from fabrication viewpoint, which is done in the country.
Okay, thanks, Subrata. I think now we thank him again for the now I invite Professor R.C. Anand, the Director of IUCAA and the Chair of the Scientific Management Board of the LIGO-India project, to share his view, especially on the community.
Good morning. I also didn't put slides, but I'll go through few points. Maybe it will be slightly scattered, but let's try to connect through the end. I'll first start with IUCAA's responsibility as it's been written in the project, is that we have to build a commissioning team. That's the first part. Second thing is that you have to build the computing resources which will go with it, go with the detector. Third things I remember is that by the time the project is started, for example, T equal to 0, once the contract is given, 3 years down the line, we have to plan the operations. So one has to start preparing, we have to lead the effort in creating the operation proposal, which will be submitted 1 or 2 years before the engineering run. So these are the things, as far as I understand, this is what our responsibilities are. But if I take a global idea of what one does in these kind of projects, not just relating ourselves to GW or any of these things, what one notices is that this is going to be the first time we are going to build some instrument. So let it be optical telescope, radio telescope. If you take the examples of, we have some examples. It's like a GMRT, which came out after the Ooty radio telescope is built. We also have an example of first Asian largest 2-meter telescope was built in the country. But all the next 2-meter telescope we have in the country is being purchased. Whereas in the radio astronomy, we started with 2 interferometers, Ooty radio telescope, then GMRT. And GMRT is seamlessly running because we have no problem. Any mistake happens there, we know how to correct it because there is a heritage in the thing. Whereas, unfortunately, I belong to the community where we failed. In the optical astronomy, we have observatories when something doesn't work, we have to go back to the people who built it, and those guys may not be there or not. So lessons learned is, when we are building this observatory, we have an advantage because we know that if we get some certain signals or whatever, some issues, we know whether it is systematic or it is kind of solvable issue because we have 2 other detectors which are there. So the idea is that the community growth should happen hands in hand with the way we are building the instrument. And when we are spending about 2,600 crores, or it may go to little more, and so much effort is going on, it is not for building only one. We are also going to, subsequently the community is to be there when GW experimental setup is keep on increasing in the global level. That should be the idea here. So we are, when we say building a community, we are not thinking of building a community which will just be there like what it happened in the case of optical telescopes. Rather, our example we have to follow is basically from the radio astronomy group, where our contribution to SKA will be substantial, not just in this thing, in the technical side itself. Having said that, I will see what is the status of various things and what we are doing when we looked at this thing. Computing, I am sure, like you already know, IUCAA runs HPC, which is supporting the data analysis of ongoing LIGO project itself. We call Sarthi cluster. And we have good experience in running the system and integrating with the rest of the things. Just before going that, when IUCAA become part of it, even before the approval of the LIGO project, University Grants Commission has approved substantial number of positions in IUCAA to support our contribution to the LIGO project. It is like, if you will be surprised, there are 10 faculty positions. I don't think any other project got 10 faculty positions focused on a particular issue. We have about 10 scientific staff, and in total about 25 members who are IUCAA members. They are not LIGO-India people. They are not funded by LIGO-India. This is funded by University Grants Commission, but it is like building a group in IUCAA, which will contribute to our contribution to LIGO-India. I think as far as scientific technical staff is concerned, we have hired almost all of them. They are in place. And then if you hire 10 people, you can imagine the labs have to be built. IUCAA is known to be a theoretical institute with a little bit of observational science. So now we have built again a new building which will host several labs. And we are also have plans in place to procure various things so that we can start various activities. So I'm hoping that next year onwards, because building is ready, now inauguration will happen soon, procurements are going on, and we will be having running labs. These labs are research labs focused on whatever we are going to deliver to LIGO-India, as well as whatever future GW-based research work one would like to carry can be carried out there. So, so what about the commissioning team? Commissioning team, I think our people in IUCAA, in consultation with various people, we have come up with various plans, and the plans have been vetted by different committees, and it is now placed in front of Project Management Board of LIGO-India. Once it is approved, we will have funding which is flowing in, but before that we are already started some activity. I will put it in a crude way because I am not coming from neither I am coming from GW community nor I am an engineer. So I will think like a common sense way of looking at it. So basically there are 3 stages of training towards the commissioning. One is that basically you want to attract interested people who will join now and be there part of this community for a longer period of time. So that is the activity we have started long time back, because this is like hands-on experiments. We have set up a lab now. Last 2 years, we have been running something called GW Winter School, where people get used to interferometers, vacuum chambers, cavities, and suspension, right? These are the things which has been introduced to them. In addition to that, simulation tools which are required to understand these interferometers are also there. And we have started at a small scale, but a bigger vision is to set up such labs, 4 or 5 labs across the country, because IUCAA we are inter-university center and we have our nodal centers across the country. We are thinking of setting up 4 or 5 such labs where MSc students we want to integrate this as part of master's programs of different universities so that they can go to the nearest centers and perform this. And it has been well received in UGC. Then we are just waiting that once it is done, we will prescribe as a course for MSc colleges to integrate into their MSc system. Not necessarily an astronomy course. It could be part of physics course itself, where 4 or 5 experiments can be done, and that will be the good thing to do. The second thing to aim for is to look at a long-term projects, a 1-year project, people, engineering or MSc students coming and spending with our team. This will be slightly more elaborate. The third stage is to have PhD. We pick some people from here, and they should be doing a PhD with us so that they integrate into the system. And definitely we have several people who can do match filtering, several people who can do calculations. So this PhD, what we are looking at is actually people who will dirty their hands with this. Okay, so that, having said that, the second thing we are doing now, I will spend more time on this because technical things we have heard from other people. Second thing we are doing is that if you want to catch a lot of younger people, immediate thing will happen in our head is to go to IITs and this thing. But if you just calculate number of graduates which are graduating in the country, IIT is very small number. And if you actually ask them how many of them will come to science and all, it is very small number. What we are, if you look at the tier 1, tier 2, tier 3 cities, they produce the maximum number of graduate students, right? And I'm sure most of us came from such universities only. So what we have done now is that we are trying to set up kind of working groups among university teachers. We know that there are about 300 professors across the Indian universities, which is about 150 universities. They are part of IUCAA's system. This is known as associateship program. They can come and do research in IUCAA. This is our major mandate. So what we have done now is that we are setting up we have sent a questionnaire to all of them, try to identify whether they are interested. They may be physicists who may be doing something else, but we want to say, here is a big project which is coming up. Are you interested in joining us in this project in various forms? And we also identified 3 things, right? One is the theoretical calculation. Second thing is the data analysis. The third thing is to participate in the technical part. So we got a lot of response. As you expect, most of the response were for the first thing. So I will calculate stochastic gravitational wave background from my favorite model. Can you tell me whether we can detect or not? So now we are asking the next question. Now that you are with students, can you identify some students who will do this calculation of data whatever analysis? The idea is that this is how we built X-ray astronomy group. You know, now the way we built was, we identified different interested people and asked them to run some projects and take some students to do PhD with them. But we helped them do PhD in data analysis part included in their thesis itself. The same thing we can do. Idea is that you may be interested in calculating something and you want your student to do the analysis and get the data, how to do it, that we can help. We means, I am not saying only from IUCAA, I am saying that LISC people, we can associate them with ICTS or with Archana or somebody. The idea is that we are thinking of finding people across the place and do this. So this exercise is going on, and Shashwat is coordinating these activities of doing this exercise. The other thing I would like to highlight on is that from the LIGO side, LIGO-India side, there are some efforts to build a community through what is known as white paper projects. So there are about 20 projects identified. These are small demonstration projects. This is allow groups to show that their ability to coordinate and perform some small experiments so that we can encourage them and we can also co-PI them to a larger project where they can start building bigger instruments. So to start with, we have identified about 5 projects for this cycle. So we have gone through the full process. We have identified the process of announcement. Announcement will be made from IUCAA. We are thinking every 6 months, in a year, 2 cycles of announcement, call for proposal. People should first write an expression of interest to us, saying that we have a group, we are interested in taking up this job. Then based on the expression of interest, and we will identify one technically competent person from this 4 institute to be to guide them through the process. Having identified these people, they will develop a bigger project which will be submitted to the committee for the funding. So this is for 3 years. Each project will be submitted for 3 years. And evaluation and other thing we have put together in a standard way. So I will not go into this. Idea behind this is also the seed money involved is very small. I think it's not, a lot of money is not there. At least idea is when you start and if you show something, we will put a broader proposal. Suppose imagine it's 1.5 crore to 2 crore. This is the kind of typical number we are thinking for the initial stages. Maybe 50 lakhs to 1 crore kind of thing. But with this seed money, if some group demonstrate, they will be able to do certain things. Then the idea is that we will put a bigger thing either to DST or ANRF or to DAE through various schemes to develop a bigger things. And not these things are, by the way, these are not necessarily the component which will go into LIGO because that will delay the process. The aim is not to make this group develop things for LIGO. Rather, we are thinking of making people who may be doing other science get interested in developing some instruments which are related to GW or interferometric kind of detectors. And once you have the community, I think it will be easy for us to see what is the future, right? So we already know that is the thing. So to enable this, I also got approval because till now IUCAA associateship program is valid only for people who have done PhD in physics, who are working in universities or working in ICERs and things like that. Now we have said that we want to widen it so that not only in physics, we are going to allow engineers to be part of our program. So that we will, and this will be targeted, and we are going to have a webinar where we are going to announce what kind of people we are looking for our scheme of things. And if we can get 50, 60 people across the country doing different kind of experimental activities, either it is thin film where they will think about coating, or people who are working on lasers, or people who are working on other kind of thing, vacuum systems. So we are trying to identify across the country. That is the thing I want to say. This is related to community development. I will spend few more minutes on another very important thing. This is not very scientific, but one has to do, is to make sure now, Subrata ji was telling that we are very lucky to get the land, and Sendil also endorsed, Sendil said that Subrata endorsed it. But holding on to that is another important point. Holding on will have two aspects of it. One is that people there should feel that it is their project and we are not there to spoil their livelihood. Okay, so this is the important thing we have to know. Another lesson learned from GMRT, you know that GMRT is running for last 20 years or something. Now suddenly the new problem has come. They want to send a railway line going through the antennas, right, where the amps. So this kind of problem can come at any time. That means we have to have a public outreach program done in such a way that they all own up to this project. But we have to also do it in a very careful way. We should not go and tell that because of this, one way of doing is that I am bringing it here and you will get a lot of benefits, you will get jobs and this and that and all, because this is the kind of thing typically we hear whenever somebody implements some scheme. So we have to play this very carefully, because this is another point, because we are looking for highly trained, skilled manpower to work in the project, where that region, what we should say, what we will give is not jobs, rather we say that we will give them upliftment by doing several other things. For example, introducing some MSc courses or introducing them to something else. So this is the kind of thing EPO we have to do, and we are into it. I mean, like that is one of the things, kind of thing we wanted to do. Lastly, this is I just going out of LIGO-India, and I just want to wear the hat of another PMB chairman of TMT and other projects. I would like to say that the communities, as an Indian astronomer, I would think that certain initiatives should come from us, independent of what happens in the LIGO project itself, because LIGO project will focus on how to detect gravitational wave, what best we will do. For that, I will say a few projects we have to integrate. I think as a community, we have to discuss and see how the synergies can be established. One thing I want to say, start with is, which is natural, is that HPC thing. You will be knowing that India has this national supercomputing mission. First part is over. The second part is being developed now, which will have a huge computing facility, right? People are talking about exascale machines being done in 3 years down the line. It's not very far away. So we are coordinating astronomy community to find out what science projects they want to do. I think that community should simulate various things which we are thinking about, and use the opportunity to make sure that we are sort of also lead a path in that direction. SKA, TMT, so the coordination between your whatever, identifying, now that LIGO-India will give you much better localization, what physics we can do, what astrophysics we can do has to be discussed as well. I think this is very important to have our own facilities, so that we don't have to, we detect, and we want to do follow-up, we don't have to run to some other observatory, ESO or KEC, where we have no direct access. Because when we have this direct access, we have to figure out how we are going to coordinate. It is not going to happen just like that, I'm telling you. See, unless otherwise we develop these synergies, it is not going to happen. Okay, that's the last part, which I wanted to again encourage GW community to push this, because this we put it as one of our vision documents when we wrote for the principal advisor to Prime Minister. We made a decadal vision document. One of the things I was proposing to the committee, and subsequently it is integrated, is that can we make, instead of looking at various other facilities, we have several 1-meter telescopes across the country. There are several 2-meter telescopes across the country. Some of them are working well, some of them are not working well. Can we find a working group where we bring all of them under a single umbrella, so that the networking of our own facilities, it may be at a moderate level resolution and moderate sensitivity, but once you integrate all of them, because of the locational advantage, there is no other network in this location, right? Either you go to Europe or you should be in the Australia and other things. So we should exploit the fact that this can be done. So I just wanted to, as I told you, I went randomly on various things. I might have missed some specific thing we are doing that we can come back to when we discuss. Thank you.
Thanks, Anand. Any questions?
So you mentioned the point of making the local people a part of the project. As far as I know, the INO and even the TMT project, due to the religious issues of the site, it has been withheld and it's not progressing according to the timeline. How do we avoid that in these projects?
No, I think, I should not say this, but I think these two, there are a lot of groundwork done by research institutes in Maharashtra. And I think we should take some bit of credit, because thanks to our founder director, Professor Narlikar, there is a lot of awareness in the state. I think it's that is one advantage of having this in Maharashtra. The second thing is that we have bipartisan support. It's not only ruling party, even opposition parties are very much in support of this project. What I meant, I don't think issues are going to say, again, we have the way, if you go to JMRT, you will see that antennas are in the middle of the field and it is running well. What I meant by issues is that issues will come not because of religious or other things, but because of our false kind of saying that like when we come here, all of you will get 1 lakh rupees per month, or you will get some facilities, you will have, world will look at you in different things. If you do false promises, at some stage, if somebody triggers that thing, then it's an issue. So you will say that why are you not giving employment? It's not possible for us to react to that. That's why I said, like, I don't think religious or superstitious things, because that is very much under control. I will not say under control. I will say that it is better being explored, these kind of things in Maharashtra, because the amount of crowd we reach, IUCAA reaches, is huge. So nowhere we are going to give any non-scientific thing. So that part is under control. I don't think we will have protest saying that this is very sacred place and you are taking it. I don't think it is going to happen. But we are worried about the other aspects, the social aspects of this, which you have to be very careful.
I see. Thank you. I was actually just surprised that this happened for the TMT project, which is not even in India.
TMT can easily happen. I think it's a sacred place. If somebody triggers it, it can happen. I don't think it is a problem. I know I am from Tamil Nadu. I know why it happened. I cannot tell it here. Okay.
I see Sendil has a hand up. Sendil, please go ahead.
Yeah, I agree here that what Professor Shrianand said, that we have to be sensitive to the local population in terms of how we control development of the site. I think partly we've been fortunate here because there was a proactive support from the local government also, the Nanded University also, and we also have from the state government a delineation zone which says what kind of development can happen around 5 kilometer and 15 kilometer. And routinely, proposals do come up for some non-standard applications, which are then routed properly through various mechanisms to the project authorities, which look at it and see if it is benign, it is accepted. If it is not, then we refuse that. So this mechanism has been working well for the last 3-4 years, even while we were waiting for project approval and the project site is approved. But having said that, I agree that if we stop development, it's going to be a hassle. And towards that effort, I think there have been a lot of other interest from some of the government leaders there, mainly Rajya Sabha members and others, to see if Nanded and related activities around LIGO-India and other could be made into a knowledge city or a knowledge hub. That is something that we would also facilitate and make sure that that becomes a kind of a knowledge hub, a knowledge park. As part of LIGO-India, we also have some money to build an outreach center at Hingoli, similar to what both Hanford and Livingston have. Called Light and Gravity. This also should encourage many local students and school visits to understand what LIGO-India is and why the low noise is important for the LIGO-India detector. I think it's a mix of these things that will help us maintain the low noise of the site. But I will still say that we've been quite fortunate given the history of INO and that we got this site quickly. And as Professor Shrianand mentioned, it partly comes from the goodwill that Professor Jayant Naligar had in the various outreach that he had done, both in Hindi and local languages also. And partly also Nanded University also is contributed to that. We hope we are able to maintain this goodwill through the construction phase and the operation phase also, and maintain the required low noise required for our site operation. Thank you.
Thanks. If there are no other questions, let's thank Anand again. And now I invite Professor Archana Pai from IIT Bombay, who is also the PI of the LIGO-India scientific collaboration.
Anand has already started talking about the community building, and I don't think so. I need to convince anyone that LIGO-India is important. So I'm going to skip few slides and directly take the thread which he started and essentially talk about where we stand as a LIGO-India scientific collaboration from the first discovery. Okay, so I'm just going to skip few slides. Okay, let's just see. Yeah, so I have few slides, which I'm sure I think some of you have already seen. I think this is one interesting slide, which maybe I think my guess is maybe Ish did talk about if LIGO India is jointly operated with CE and ET and how the prospect of source localization is. So I thought it is quite interesting because often we talk about what kind of sensitivities the LIGO India will have, and what is the timeline and things like that. So I think basically it sort of summarizes that. I mean, if we have LIGO India either operating as A plus or maybe A sharp, so there is some other work which has been sort of carried out here. Okay, so there is this work which is, I think, Anand and his group, they talked about if all the other detectors are with their sensitivity, but let's say LIGO India is at 04, maybe low sensitivity, but still we have improved source localization. So I think basically the bottom line is, I think LIGO India is interesting in terms of the science prospects. I'm going to skip this slide. So basically the key message all of us know, and I'm sure I think it must have been talked in the meeting all through the week, that LIGO India is going to bring better detection rates, better sky localization, parameter estimation, and all the consequent science which we can bring with the multiple detectors. So now the question is where the LIGO India scientific collaboration, where we are right now. So if I just want to remind people that 10 years back with the first discovery, essentially we were 61 members, out of that 31 authors on the discovery paper. And there were essentially 9 institutes involved. And now the whole landscape has changed. So now currently we have 17 institutes, and the number, the authors have almost doubled on the LIGO papers. And the interesting thing which I would like to mention, I think taking up Shriyanan's thread, so now if you look at the institutes here, there are of course LIGO India core institutes, and also there are institutes like TIFR, IIT Bombay in Mumbai, Pune we have Iyer Pune, IUCAA, ICTS-TIFR, Kolkata we have Iyer Kolkata, there is CGCRI, Saha Institute. Then RRCAT, of course. Hyderabad, we have IIT Hyderabad, and Chennai, we have IIT Chennai, CMI. And I would like to sort of make a special note, which is the direction along which I think these are the 2 new institutes. I mean, of course, there were other new institutes also. But if you look at, let's say, this institute, this is NIT Calicut. So this is, we have added very recently. One of our student who did postdocs abroad, came back and joined as a faculty. His name is Harris, and he has started a new gravitational-wave group there. And similarly, there is another new institute. This is a college, actually, Government Victoria College in Palakkad. The PI is Prashia. She was actually a postdoc in IUCAA, and she has started a new group. I would like to mention this particularly because this is actually a government college, and as Shriyanan was mentioning, that when we are going to do community expansion, I mean, we expect that people at various colleges might get interested, and once they sort of acquire adequate skill, then they can contribute more meaningfully in the science. So I think Prashia is a classic example, and we are very happy that this new group has been added in the LIC, and basically she's contributed to the LIGO science. In fact, she's actually contributed to the O4, one of these O4 studies. So I think we wish to add more such colleges, after as a sort of result of the community building. And we expect that if that happens, because especially this college has a lot of undergrad students, and if they can get involved, I think automatically the community grows. And I think that is something which we are more focused, and that is our sort of broad goal. Now, with that, of course, I think with more institutes, our core current strength in research, in LIGO research, have also increased, and we have expanded in various research sort of focuses. I mean, I think to start with the searches and waveform development, and of course, test of GR during the first event. Now things have been expanded, namely people are working on looking for lensing signatures, trying to understand the degeneracies with waveforms, which can sort of make big difference. Probing formation channels, then probing cosmology, neutron star equation of state. Also, early warning and EM follow-up. I mean, this was also sort of, there is a lot of work was done with 17 following up with several telescopes, I think, as Shriyanand mentioned. On top of it, there is also work started on detector characterization and developing ideas of discriminating signal and noise, especially for different classes of glitches. There is some work has started on the R&D work on detectors, I think primarily working with people with the core LIGO-India institutes. And last and not the least, I don't know if I have missed out something, I'm sorry about that, but I am quite happy that, there is things have really expanded in terms of research and actual direct contribution to the LIGO papers. The last and not the least is essentially, I think, some of our young members, especially students and postdocs, they're actively involved in this rapid response team of the collaboration, where they contribute in bringing out the LVK alert, and they do these shifts, almost day-to-day basis. So I think we do feel that, I think on various domains, the LISC community has sort of expanded, and it is also expanding. So if you are interested, or then we would sort of, urge you to please contact us, and we would be very happy if you would like to form your group at your place. Of course, I think all through the meeting, I think there has been a lot of discussion about various interfaces with astro, cosmo, gravity, high energy. Of course, there are several open questions which can be addressed in the multi-messenger framework. And there is a lot of work which one can also do with the open data. So I think engaging with the broad community, I think we can make best use of the open data as well. Nevertheless, we also know that the Indian pulsar timing array community is also growing, and they're heavily engaged in the INPTA activity. So we are also are very in close sort of contact with them, and there are avenues where one can explore multi-band, multi-messenger observations in future. So at this point, I would like to sort of mention that we are trying to do various efforts in actively trying to reach out. So one way is we actively sort of highlight regularly the LBK scientific discoveries where the LISC members have contributed. There is some periodic update about the project, which I think the core LIGO-India Institute, they are involved in. There are various meetings. I think the meetings like this can be the platform to, exchange the ideas. And I think, such meetings are fortunately happening. I think thanks to ICTS-TIFR, I think they've been very active in doing this. And there have been also a regular activity of basically doing open data workshops, including LISC institutes. We do this across the country, and we want to enhance this, trying to engage more institutes to conduct this locally, so that we have seen that there are benefits. The undergrads do get engaged and take basically best advantage of that. We are also trying to expand this, because currently this open data workshop activity is only focused on on primarily searches and parameter estimation, but I think it would be great if we can expand this. And I think there are some efforts, thoughts in expanding this activity towards some detector-related activities along with the LIC members. And there is lately the engagement of the undergrads and post graduations in various research projects in the LIC institutes have also increased, and that is definitely towards community building. In fact, I just want to quote that in the last year's Astronomical Society of India meeting, there were 16% of the participants were undergrads and postgraduates who had presented their work. So overall, pan India, this whole the increase in the interested undergrads and postgrads numbers are increasing, and I think that is something which we are also trying to sort of take advantage and try to train them and try to get them interested in taking up gravitational wave as one of their sort of career options. So I think with that, I'm going to stop. I want to thank and this is, if anybody wants to reach out, I mean, this is where we are. So yeah, thanks a lot.
Thanks, Archana. Sukant has a question. Any other questions specific to Archana?
Hello, Archana. This is Sukant.
Hi.
Thank you for this talk. It's great to see that community building remains quite robust. I recall that when I first joined the earlier version of the LIGO-India project, something like in 2013, one of the questions we used to often get from various quarters, be they the science bureaucrats, even the scientific advisor to the Prime Minister then, or even politicians, was, where is the community that is going to use your detector?
That's right, yeah.
So no, happy to see that that activity continues. And also, given the timescales of detector building and operating, and also the future of this field actually deserves a rich community, rich in experience and expertise. On a lighter note, I will point to the fact that one of the plots that Sendil showed, and since we have not lost him yet, it's good he is hearing this. This was the sky localization improvement when you bring in LIGO-India, which was attributed to Kip Thorne, was actually made by young members of this community, some of whom are here, students, postdocs, and faculty members. This was a LIGO-India science paper. But Sendil, it's good to see that Kip is actually showing that plot and advertising the project. Thank you.
Yeah, Sukanta, this was a slide I borrowed from his presentation that he made to the ETG. Before we had our approval, we had the Empowered Technology Group which met of the Government of India, and Kip was invited to make a talk there. So this slide I borrowed from him. I am aware that the inputs came to him from various Indian colleagues, but I just borrowed the slide in toto. That's why I kind of credited him for that.
Yeah. No worries. But good that, I think I just wanted to highlight the fact that that contribution was very valued that came from some of these junior scientists. Thanks.
Okay, if there are no other questions, let's thank Archana again. Okay, now I would like to request all the panel members to come here, and in case there are any general questions remaining in the audience, please. And online, Sendil and Archana both are there. So, so now, here is your last chance.
Last chance of the day means we hope
for this day. After, if you don't ask your questions now, you cannot say that you don't have any clarity on LIGO-India project from today and before.
Hello. Yeah. No, so this general question, I think maybe for everyone, that is on the part of outreach. Particularly, I think Anand talked about how the villages, like local outreach has been done, but I think there might be scope for in general country-wise outreach. And especially when I saw a lot of technology development is happening, and a lot of things which will go in long run in terms of countries' development. And the public perception for such mega projects is important. Like you look at what is happening with Chandrayaan and all. So I think individual institutes, maybe IUCAA acting as a node also, because having the expertise, I don't know how that logistic, it has to be like go in next 5 years, it has to go literally to the public as much as possible. probably also maybe going into the books of students like NCRT books or schools that like this is a big thing, we are detecting things and how it is impacting countries' technologies, how it is impacting the common people, like some of the technologies which have come through. Also maybe just list them out on the web pages that, oh, these kind of things help, like lasers built us for some other things. And also I think that goes a long way in general getting approval for future projects also.
I agree, but yeah, I think this news that something we are building, what science can be done and what is being done by the community, I think I agree with you, it has to be communicated. Yeah, I don't see any reason why we will not do. Only place where I have some discomfort with some of my colleagues is to go to newspaper every time, right? Every time you sneeze, you say that it should come. Probably that we will avoid just to make sure that, so I understand the way we should plan is that every milestone achieved by LIGO-India should be highlighted and widely publicized. And there is a plan that I think Sendil will tell also. We can make a material which can be made by the core team, which can be used by other people across the country to publicize. So that can be done. For example, once the contract goes and the groundbreaking happens, I think that should be celebrated and probably, so that kind of things we can do. But it's also possible that being a large project, I'm seeing that what you may be thinking that why are we not hearing from the team very often? Why can't public be going in this? That I'm saying that part maybe we have to be very careful in what we are doing. But the other point you mentioned about going and outreaching to nook and corners of the country and saying that this activity is happening and we are going to be having a detector which is the best. That is that we have to do. I think this is one of the thing which came out of IUCAA internal meeting. So now I just tell you a few things we have done in IUCAA. Probably you may not know now because each faculty is now adopting a state. Okay. So just for outreach, we have done two ways. One is that we team-wise, we are building working groups. Second thing is that each region, we are now identifying coordinators. For example, I have adopted now Tamil Nadu and Andhra Pradesh, right? And you are something, right? Now see, he's not adopting anybody, okay? So like this, each one of us, we have adopted, and the idea is that when we put IUCAA's imprints in the Indian map, we found that there are about 6-7 states where we are so concentrated in our activity, and rest of the states we were not. So northeastern states, for example, it is done. And another thing we decided in these meetings is that when we organize workshops or something, there will be special session where we will highlight these kind of things, opportunities available for people. For example, I was in Central University, Tamil Nadu. Can you believe I was talking about LIGO-India and what can be done with the students, because we had sessions where I talked about opportunities with SKA, opportunities with TMT, and opportunities with LIGO-India. So I see that this is there in pipeline, but we'll do it in a systematic way.
Also, we are doing some workshops in tech-based workshops, etc. in various.
No, but I think he's even going to the public level, right? You are saying.
We are gaining as a country. So for general public, like, okay, you did like detect something astronomy, but what is us coming out to us? Like when you're, so those things to be highlighted that, okay, we have developed some laser techniques or which could have industrial applications in I don't know, like there will be some these things for sure in terms of a lot of technology, vacuum system coming up, direct application to this. This goes long way, I think. I mean, a lot of people, I mean, don't know, like, for example, GR is needed for GPS. Wi-Fi was invented in this thing. So this,
I think this is collectively done. I think this is what.
Yeah. So this just highlighting that goes long.
This is what Archana is showing her hand. Probably this is also one of the activity. LIGO Science Consortium can take it up, right? Because
exactly. I think that's what I wanted to say. Yeah, that's what I wanted to say.
Because people are spread all over the place.
Correct.
So all of us should do it.
Yeah.
Your hand up is regarding this, or you had?
No, it was regarding that also. And I also wanted to say that I think everybody, all of us do it in our local, this thing. So I think, I mean, it is done actively. Maybe what you mentioned was specifically related to the detector. So I think we'll try to also expand and, include that in our regular talks which we give public as well as at college level at on various events. Also, there are lots of tech fest and other activities which we conduct on the regular basis. So I think there also it can be done. Yeah, sure.
I
Thanks.
think it's a good suggestion, and also whatever we have right now, like the fiber pooling facility at RRCAT or the vacuum, etc. I mean, these are also can be projected, I think, in social media. We have to just
This is why I want to be careful. There are certain things. See, when fiber pooling we are learning, we don't want to go into the public. Those guys should be left alone to do what. It's my personal. I'm not talking in terms of LIGO-India or something. People who are actually doing technologies and developing something, actually building LIGO detectors and all, should be left out of going public. I think we should take the responsibility of, people like me should take the responsibility of taking their news to public, because they should concentrate on delivering the, this is my personal view, it may differ from people.
So, so just to respond to that about fiber pulling in particular, it makes a big impression, especially on younger students who come to visit, when you can show them, which I believe they can at Hanford. We don't have an example that you're hanging the glass from glass, you know, and that it's very strong. Yeah, so you can't completely conceal. I don't think you should conceal the science completely, because there are some interesting things that will spur imagination.
I'm not saying concealing. I'm with you in this. Only thing I'm saying is that all of us should pitch in. People who are doing this, let them do, and we learn from them and we use that. This is my point. I'm saying this. When it comes to public outreach, it is each one of our responsibility. You can go and tell this to people. Only thing what we can uniformly do, which we can request from the project team who's building, is to make material which is authentic, so that all of us say the correct things. Right? That we can ensure. So, but then you take that material, it should percolate, like cascading is much faster than centralized distribution. So we can do that way. I think that's.
Moving on, Bruce.
Yeah, so one of the things I've become aware of now, just in the last few days, is a key difference between LIGO-India and the two LIGO sites in the United States. LIGO Hanford is near the LIGO nuclear reservation. It's near Pasco and the Tri-City areas. There's school systems, large cities there. LIGO Livingston is near Baton Rouge. There's, again, a lot of infrastructure, people, schools, and so on. LIGO-India is in a very isolated site, I've now understood. The closest city is 12 kilometers away. Then there's another larger city 70 kilometers away. And I have observed over the years that people in India often tend to travel for education and to get experience, but then like to move back again to where they have family and homes. So I would suggest that when you look at your outreach, it's important to do outreach for all of India. You're a national mega project. You want to get the best talent in India, absolutely. But I would suggest that you also focus specifically some of your outreach on those two towns nearby. Meaning that, for example, you help the math and physics programs, and you make sure that there's Arduinos available for any kid in any of those towns who wants one. You make sure that there's people from the sites who go there and give lectures constantly in the schools. And you especially target the kids who are now maybe 8 or 10 years old. Because by the time that LIGO-India is operating, those will be people who could actually be working at the sites. And I look, one of the reasons why the LIGO experiment was successful was because a number of people, I can name some of these people: Rick Savage, Greg Mandel, Ryan, Joe Giammi. There's lots of people who Daniel Sig, they moved out to the sites and they built their lives there. And those people were crucial for making LIGO work. So I think you should invest some of your outreach very locally in those two towns, specifically aiming at the children who are in school now. Because some years from now, if some of those kids, if you can capture them now and get them a good education now, they'll come back home. And they'll be some of your key staff members 15 years from now.
I think this is a very good point. just for when we are talking, I wanted to update you on some very recent development. Our Pune city, the organization of Pune city suddenly decided that they want to make young children in rural areas around Pune city interested in space programs. So you know what they have come up with? They said like they want to attract students in the same category. That's why I said I want to tell you something. It is between 6th standard and 8th standard students towards space. So what they said is that they have an MOU with us, IUCAA, to see, can you identify 25 students every year to whom we will send once to ISRO, this is our space research organization, to spend a few days there, and then you send them to NASA for just to visit. I don't think they are going to learn anything, but the impression they are going to get. So what we have done, this we have successfully completed. We started from 17,000 students. Then we went through, they wrote a simple exam. We have some exams in which space-related questions and were asked. From there, we selected about 250 students, and then they went to personal interaction in the general knowledge, and we have identified 75. They have already spent time in ISRO, where they were shown sounding rocket launch, and they talked to several people who have actually worked on various missions. And yesterday, I heard that they got visa to go to NASA. Actually, they are going to US now. They are going to spend 10 days visiting. At that time, I was asking, can we arrange similar things for that? Maybe one thing we can do is to local Jilla Parishad people, we can talk to them and say that we have done it in Pune, and whether we would like to see, we are also producing now reading materials for the students so that they, before coming to exams or something, they also know that what is going on. A small thing in the local language plus Hindi and English has been prepared. I was wondering whether we can do this like this for, because here we can ask very simple questions related to gravitation. Nothing to do with, they need not do a lot of things. Maybe if they can do a little bit of exposure to this and identify a few kids, bright kids from the local schools, then maybe we'll see like whether they can get exposure to these interferometers. I just asked Sanchit whether we can do or not, but then we didn't push it further than that.
What I had in mind was slightly different.
No, I understand what
Not so much marketing, it's actually improving the quality of the
That's,
education. And there's one other side benefit that will get you. If you can improve the teaching in the schools,
Yep.
you will get support for your project of the most fundamental kind.
I think it's, I completely agree with what you said. I was just giving you,
very attached to you.
No, I was just giving you an example of the fact that you touched the correct age group. And the kind of videos produced by these kids who are selected, you will be amazed. There are some kids who have never seen aircraft, they have never traveled in train. So when they went to Bengaluru, the kind of feedback we got was amazing. Okay. By the way, Sendil can confirm it because we also have a MOU or something with the local university to include gravitational wave science in their curriculum. We were thinking of setting up some activity there. That area comes under, the whole area comes under a particular district, and the district has what you call science popularization team, right? This non-professional amateur astronomy groups. There are 3 groups of amateur astronomers leading up to 10,000 people with whom we are also interacting, and they are also spreading, they bring students. I mean, like our science day, they bring about 1,000 students in 4 or 5 buses from there. So these interactions are going on. I completely agree that what you are saying, if you are going to change something in the educational system or if you help them with some material, we will try to do that. I'm in favor of what you are saying, and I will tell our team to explore that possibility.
I think we can also say what we are doing right now. See, a lot of activity has happened. Like people like Bhushan, etc., went to remote villages.
Night skies programs.
Of distribution through the new
telescope making workshops. They make telescopes.
Many things have happened.
Talking about something more fundamental now. I'm just making sure that I'm talking about making sure the kids who are 8 years old learn mathematics a little bit better.
This is for them.
I'm thinking much younger than that and much more normal.
Schools are like 1,000 schools. You cannot.
No. See, it's not like these schools are. It's not that this region the schools are in underprivileged or something. They have proper educational system. Proper things are going on. But what I am endorsing is that the scientific approach towards something may not be taught here. This is where we can pitch in. So there are some examples of giving toys, scientific toys things. which has been done as well, because these regions, you use the waste material, you produce toys. So that workshops are held. So I also understand that producing some material which they can use, producing some toys they can, some tools they can use, this we can do. It's not a problem.
Okay, now it is working. Yeah. So see, there are some colleges there, engineering colleges, and they are taught some courses. Okay, so we are thinking that we'll do a training of those students, teaching them something which is related to LIGO-India, but not necessarily they will get engaged to LIGO-India. So which that will sort of give them an upliftment in their overall academic career. They may want to go to industry and so on. But then some of them, a small fraction of them may also come back and help LIGO-India. So we are not promising jobs, but we are saying that because the scientists are coming.
No, I think we will take it in the positive spirit like this. There should be various ways of reaching out to different age groups. And what Alan is saying is that you target these younger kids, because they will remember, and if they are excited, they will be the long-term investment, right? That we will explore what all can be done to this group of people.
In those two cities that are close to the site, specifically.
Sendil was saying something.
Sendil also has hand up. Please go ahead. Archana first, maybe. Archana had raised hand first.
Yes. Can I say? Yeah. Hello?
Please go ahead.
Okay. Yeah. I think I really liked Bruce's idea. So I think if we can put together maybe a team of volunteers in local language, and if we could do that, I don't know. I mean, we need to work together. I mean, I personally would be happy to go and, go there maybe once a month, and if we can identify some schools.
I mean, we have created a full list of schools. It was
In
like
fact,
1,000 schools.
Yeah.
All those things were, we have.
No,
Confused. The
Sanjeev.
closest town has 12,000 people who live there. How could they have 1,000 schools if they have 12,000 people?
That area is very large. On the map, it looks small. It's a very large area.
No.
That is a very big city.
In the whole district, those are the district headquarters, that Hingoli and Nanded. Nanded is a pretty much mid-sized town. It's not that small. It has an airport, and also actually flights have started again. So it's population would be okay. I have to check the population. It will be like 50 lakhs or something. No, 110 lakhs, 10-20 lakhs. Can somebody check?
So Hingoli is 12,000 people. That's the closest town.
No, Hingoli already has some 4 convent schools and 1 government school. So.
Sendil is saying some number.
Thing is, there are lots of scattered pockets of population and schools. Hingoli district has 1 lakh, over 1 lakh people population, but the Hingoli proper city indeed has tens of thousands.
So 1 lakh is 100,000 people.
That's the nearest one.
Yeah, I'm thinking specifically the towns. Yes, that's what I'm saying. Thank you.
We did that like some, but not in this way.
I think, see, now that
I think,
also excited.
yeah, I think.
See, LIC has to do something. So this is
I mean, I'll be happy to do this.
So actually, you produce some material in Marathi. This is very good. Actually.
Yeah, I think.
So what she's asking, I think, let you come with a proposal. Let LIC take consult with Alan.
Yeah, I think we can just visit some schools, and I think those who are interested, I think just we have to put together few volunteers who are really interested. This is something which is slightly long term. So
that is this Vigyan Parishad, Maharashtra Vigyan Parishad is in touch with us, and they will have volunteers. See, once you have the material, spreading across that place will be easier. Yeah, that's not a problem.
May I mention 2 things that we have done?
Yes.
Please.
Sendil first. Sendil, please go ahead. Then Sukanta, then Suresh.
Yeah, this was in fact a follow-up to the previous question. Somebody mentioned about the outcomes of the technology development or consequences of LIGO-India detector activity that benefits other things. So this was something that was kind of grilled when we were seeking approval as to how does LIGO-India benefit in our things. And we have a kind of a draft documentation, which we prepared at the time along with Rana, how it had impacted the US technological scene and how it is likely to impact the Indian technological scene. And both IPR and ARACAT have incubation centers now. And we are making sure that technologies which have larger benefit are incubated and transferred to industry. And we also have what's a technology transfer register that we are maintaining for LIGO-India to kind of capture what tangible, intangible benefits the project brings other than the fundamental science part. So that we are keeping track of and make sure that that is made available to the larger set when we do go ahead with the project. Yeah, I thought I'll just make that comment. Thank you.
This is somewhat of a change of topic, maybe more directed to Subrata and perhaps partly to Brian. Spiral bending those beam tubes, right? Yeah, I realize there are pros and cons of both models. One where you transport them, you build them elsewhere, transport them, but then we are talking about confronting maybe some hazards of road transportation on these roads, right? And because dense endings can happen, have happened. But on the other hand, yeah, building on the site will not suffer from those worries, but then the summers in these regions are extended. I mean, doing that in Hanford or Livingston itself was a challenge. I know Ray Wise was there, Fred Robb told me, working with the Chicago Bridge and Arun, right? But do you think this is, maybe I don't know enough. How well can they do this job in those kind of heat, that kind of heat, extended periods?
Hello. See, even if you make them elsewhere and transport, it will be till the same amount of summer heat they will face. And even during when you are going ahead, joining each of these beam tube sections, the temperature remains the same. So, but only thing that is, our preference is actually if they make 20 meters at site, you can probably see that there's also a clean room in that, in the place where you make it. Because you clean room, you qualify for the leak rate, then each of these sections are again packed and then transported. Maybe now, because it is at site, maximum would be 7-8 kilometers from one corner to the other corner. So, but the heat remains. So, and there's no way we can avoid. If we avoid the 9 months, we cannot do anything. But that's we have to live with it.
Yes, so it gets extremely hot in Louisiana, extremely hot and humid. But if you've been to Louisiana, there's roads, there's bridges, there's industry. So people are very adaptable and companies figure out, I mean, I wouldn't want to do it, but people put roofs on in the middle of summer. And so they figure out how to do it and do it quite well. So I don't think it's pleasant, but it's not, I don't think it's something I would consider a showstopper for the work. I mean, these companies are used to working, I think, all over India. So they're probably used to, you know, they don't destroy their labor force by making them, you know, working them to exhaustion. They know how to accommodate cooling breaks. We do all this ourselves when we work outside. And so there are ways of addressing that. I don't feel that will be the thing that holds us up. Maybe the continuous process might be more difficult. That's Subrata talked about.
Yeah. Last point.
Last question.
Yes.
Because
not
the
a question.
get a bit delayed.
I just wanted to touch upon 2 programs we have done to reach out to school students. Typically, we have worked through the local science clubs and astronomy clubs in the region. They are very well-established science groups in the region who are regularly going out to schools and educating the children with night sky watch and all of that. Then that is one thing, that is on the private sector in some sense. We also reached out through the government, through the district collector and the government schools. We have donated telescopes, we have donated kits, and our personnel have gone. But I agree that it is an intermittent contact. We do it like maybe once a year, once in 6 months. It's not a regular thing. But I agree with Bruce that we should have a regular presence and we should organize this better.
I know. I mean, I think that what happened is that there were more people there than some people left in between. So it went down a little bit right now. But again, we are in the process of hiring people.
Or whatever.
Long-term.
A long-term employee somewhere. So we'll.
Earlier when they left, now again, so there was a pick up. So it should pick up. Professor
No, this is what I mentioned because they are asking us to, it's the same lab they want to build. The whatever we are doing in IUCAA, that LIGO instrumentation, whatever experiment lab, they want to do that. And they also want to build some kind of exploratorium kind of thing, highlighting LIGO science. So there is something there in that. Yeah.
Sorry, this is some different aspects. How aggressive is this LIGO-India program on social media? Because I am from Madhya Pradesh, which is one of the not very developed states. So school students have no idea about LIGO, gravitational waves, but they have idea about NASA, ISRO. So how aggressive are we or as a community to have this? Because that is some, what I'm talking about is to develop what you call a scientific temperament for all. That is a most, I think, important thing for students and kids to have a scientific temperament. Even they don't come to science maybe. Maybe they go on to something very mundane job. But how aggressive we are on promoting this on social media, because that is a very strong thing now, because everywhere in the country, people, not only in Maharashtra where this LIGO-India is coming on, this is going to be all over India, and people will be looking into it. How aggressive are we on that?
I think say one thing, it's not very clear to me, but whether social media's learning science from social media is against scientific temperament or not.
Not learning science. I'm talking about getting an idea of what are happening.
That is right. LIGO-India has a social media, and you can go and check. See, I'm not a social media person so much, except that for this job sometimes I have to check. That's about it. But there is a strong. I mean, everything which happens are posted. Some of the things which are not posted are because we have to make a plan. But I think to the level you are talking about, at school levels, etc., a lot of things are posted on Instagram and whatever.
Is it as aggressive as other thing?
Level of aggression you want.
Aggressive means in the sense that promoting thing.
Like they are there on social media. What else can you do?
I don't know what else that is something.
They are all posted. I mean, we also contact the press people to somehow highlight, but not like there are all India, like local, those things are done. But yeah.
I think it's important to have some perspective. So I'll go back again to the first detection when we were working on publishing the result. There were a lot of meetings, and I was on these meetings and, in my dining room, and my wife walked by as somebody was saying, how will we say this? What will people think? And at the end of the call, she was laughing and she was like, what will people think? She's like, most people won't really know, even if it's like the biggest news that you've ever had. And so at LIGO Livingston and at LIGO Hanford and at AUNDA, there will be an outreach center. And if it's anywhere like the Hanford and Livingston experience, you'll have something like 10,000, maybe more, school students and students of various stripes and other visitors, at least 10,000 per year come through. And we've been doing that in Louisiana for almost 20 years now. And the outreach effort has gone beyond that. And I still regularly meet people who have no idea what LIGO is. So you can do a lot of social media and newspaper articles, but the fact is that still a lot of people will not have heard of the facility. Now, The people who are interested in science will hear about it, but you can't saturate it. It will never compete. It won't compete with a rocket launch, and it won't compete with whatever the favorite, I don't know, Bollywood star maybe in India or cricket player. You just can never rise to that level. Maybe very briefly if you see something very exciting. If Beetlejuice blows up, then maybe people will learn a little bit about LIGO and gravitational waves and astronomy. But it will take something at that level.
I think we thank the panelists now.